So this video is on Karnaugh map. The Karnaugh map that can be represented as K map, a visual way to simplify the logic expression. So this helps to give a visual way to simplify the logic expressions, and it gives the most simplified form of the expression. The rules to obtain the most simplified expression is given below. So in general logic Boolean simplification of expressions, it lacks specific rules to predict the most suitable next step in the simplification process, and it is difficult to determine whether the simplest form has been achieved. A Karnaugh map is a graphical method used to obtain the most simplified form of an expression in standard form, either in sum of products or in product of sum. The simplest form of an expression is the one that has the minimum number of terms with the least number of variables in each term. By simplifying an expression to the one that uses the minimum number of terms, we ensure that the function will be implemented with the minimum number of gates. By simplifying an expression to the one that uses the least number of literals for each terms, we ensure that the function will be implemented with gates to have a minimum number of inputs. So let us see how these can be obtained. First we are going to start with the 3 variable K maps. In a 3 variable K map, so let us say that we are giving f is equal to summation of 0, 4. So as far as 3 variable map is concerned, see, we are drawing the K map with 3 variables as A, B and C, in which in the table we need to write 0, 0, 0, 1, 1, 1 and 1, 0. And for A, as there is a single variable, there is only one combination 0 and 1. So now this function is given as f is equal to summation of 0, 4. As you see here, for the various combinations various combinations of A, B, C variable. So for the first cell it is 0, and for the next cell C it is 0, 0, 1 and it is 1, and this is 3 and this is 2 and this is 4, and the cell it is of 4, and the cell it is of 5, and the cell it is of 6, and the cell it is of 7. Okay, now for the given function f is equal to summation of 0, 4, see, we have filled the cell with 1 and 1 for 0 and 4th cell. So now for the combination of 3 variables, for the combination of the ones in the K map, either 2 ones can be combined or 3 ones should not be combined. Either 1 1 should be combined or 2 1 should be combined, or 4 ones or all the 8 ones. Okay. As far as this K map is concerned, as there are 2 ones, now we are combining these 2 ones. So as we are combining these 2 ones, and if you see here, this can be written as A bar B C. Is it A bar B C? So A bar B bar C bar plus for the another C1. See, for this one it should be written as A B bar C. A B bar C bar. Is it? And if you take B bar C bar as common, your A and A bar will turns to 1, and now our simplified Boolean expression is B bar C bar. Thus, on seeing this K map, it is directly written as, see, if A is varying with zeros and ones, it meant that your A will be get cancelled and you will get only B bar C bar. Okay. Thus, for this given Boolean function, the simplified Boolean expression is B bar C bar. As far as the next function is concerned, see, it is f is equal to summation of 4, 5. So this 4 and 5 is given substitute with 1 and 1, and remaining all the cells are filled with zeros, and as there are 2 ones, we can combine horizontally. Either you can combine vertically or you can combine horizontally. Hence I am combining horizontal way here, and if you see here, during the combinations, in this case your A is compulsory present and your B is common, and if you see your C, it is varying from 0 and 1, hence it will be given a final expression, simplified expression as 1. Hence we are not choosing your C and C bar. Hence we are considering only A and B bar. As B is 0, we are considering it as B bar. As A is 1, we are considering it as A. Hence the simplified Boolean expression here is AB bar. And if you move on to the next function, f is equal to summation of 0, 1, 4, 5. See here 0, 1, 4, 5. Is it? In these cells the ones are filled and remaining all the cells are filled with 0. As there are 4 ones are there, and we can combine all these 4 ones. Okay, and if you see here, the A variable is varying from 0 and 1 and C is varying from 0 and 1. Hence there is only B bar, the B is with 0. That is common for all the cases. Hence the simplified Boolean expression here is B bar, as B is 0 here. And if you go on to the next Boolean function, f is equal to summation of 0, 1, 2, 3. See here in 0, 1, 2, this is 3 and this is 2. Is it? So now all these are filled with 1. Remaining cells are filled with 0. See, remaining cells are filled with 0. As the 4 ones are horizontal, see, we can able to combine all these 4 ones. And if you see here, your B is varying from 0 and 1. Is it? And your C is varying from 0 and 1. Is it? C is varying from 0 and 1. Hence, we can write for B and C as 1 and A is here as 0. Hence, we can write it as A bar. Okay. If the 1 is present in these cells of zeros, at that time we need to write it as A. Okay. As here A is 0, we are writing it as A bar. Okay. And if you move on to the next Boolean functions, f is equal to summation of 0, 4. See, I am writing here as 0. Sorry. See here it is 0, and then if you see here it is 4. Is it? Actually, this question is wrong. Is it? It should be written as 1 and 3. The question here should be 1 and 3. See, this is 1, 3. Okay. As 1 and 3 are given in the Boolean function, see, I am writing 1 in the corresponding cell and I am combining these two ones for my simplification. And if you see here, your B is varying from 0 and 1, and hence it is equal to 1. Hence, if you see A, it is of 0, and hence we can represent it as A bar, and as C is here, it is with 1. Is it? And it should be represented with C. That is why the simplified Boolean expression is with A bar C. In the same way, if you see here, I am coming back to this function f is equal to 0, 2. Okay, this is 0 and this is 2. As there are 2 ones here, we can combine these 2 ones in this way. And A bar is here, as it is A is 0, and if you see here, your B is varying between 0 and 1, hence this is turned to 1, and as C is common for both the cases, we have to write it as C, is it? And as this C is 0, we need to write it as C bar, and similarly as A is 0, we need to write it as A bar. That is why the simplified Boolean expression here is A bar C bar. Okay, and in the same way, if you come back to the next function, f is equal to summation of 0, 2, 4, 6. See here, I am writing it as 0, 4. Is it? This is what it is expressed in the K map. As the ones are filled in this corresponding cells, it is as there are 4 ones here. These 2 ones of 2 and 6 and these 2 ones of 0 and 4 can be combined. And now we have combined 4 ones, and if you see A, it is varying between 0 and 1, and this is turned to 1. And if you consider the B, it is also turning between 0 and 1, and this is also turned to 1. And if you see the C value, see, it is maintained, it has same C, but it is of 0, hence we are writing it as C bar. That is why the simplified Boolean expression here for this given Boolean function is C bar. Okay. And if you see here, see, I am considering these 2 examples. I am considering these 2 examples for our simplification now. See, I can combine these 2, and then I can combine these 2. Okay, and this one is not nearer with any, hence it should be combined with a single one. Hence, see, this I can represent it as product P1, this I can represent as product P1, and this I can represent as product P2. Okay, and the single one I can represent it as product P3. Okay, so now I'm writing the equation for product P1. See, the final function, simplified Boolean function for the above K map is, see, for product P1, your A is common, is it? See, as this is A bar, as this is 0, this can be written as A bar, and here we can write it as A. As it is 1, we can write it as A. Okay, hence we can write A here, and for this product, see, your B is common for both the cases, hence we can write it as B, and one is varying between 0 and 1. This is the first term of your product. And if you see the second product, so it is also A, and your C bar is common for both the cases. So for product P2, if you consider, see here, your C bar is common and B is varying between 0 and 1, hence that should be neglected. So which means that is equal to 1 actually. That is why we are writing here as C bar. And for the product P3, you can write it as A bar, B bar, C. Okay, so as this is a single one that is combined, it is not combined with any of the ones, hence we need to write it as C. This is the A bar and this is B bar C. That is why the final simplified Boolean expression is written in this way. Okay, so now if you come back to the next K-map that we have chosen here, see, I can combine all these 4 ones and then I can combine these 2 ones. Here I am having only 2 product terms. Here I am having only 2 product terms. See, the product term here can be represented. So I am representing this as P1 and I am representing this as P2. Okay, this is P2. Now the simplified Boolean expression for this K-map is, see, it's a 3 variable K-map, right? Hence here your A is changing between 0 and 1 and B is changing between 0 and 1. Hence you will get only C. C is common for both the cases. Okay, see, for all 4 ones your C is common, which means that it is equal to 1, hence we are writing it as C. Okay, this is for the product P1, and for the product P2, your A bar is common, okay, and then your B is common for all the ones, all these 2 ones. Okay, but your C is varying between 1 and 0, hence it is not necessary to write it. So that is turned to 1. Hence the simplified Boolean expression for this function is F is equal to C plus A bar B. And for the tutorial you submit before the last date about these 3 K-maps. Okay, in the next class we will discuss about the 4 variable K-map.